welcome back. I'm glad you've returned to the silence. We leave the familiar behind to witness the silent beauty of the cosmos as we begin our long, drifting journey toward Neptune, the distant and mysterious blue guardian at the very edge of our solar system. Out here, billions of miles away from the warm embrace of the home planet, the solar system changes its character entirely, fading into an ethereal realm of deep shadow and profound cold. We leave behind the rocky inner worlds and the massive gas giants to approach a place where twilight is eternal, and the sun appears as nothing more than an exceptionally bright star in the velvety blackness. It is a world wrapped in a blanket of rich, mesmerizing azure, a color so profound it mimics the deepest, unexplored oceans of Earth, yet it remains fundamentally alien. As we drift closer, the sheer scale of this lonely giant becomes apparent, suspended perfectly in the void, a testament to the quiet grandeur of our cosmic neighborhood. We are entering a domain governed by unimaginable forces, where the boundaries of planetary physics create phenomena that challenge our terrestrial imagination and invite us to wonder. The stillness we perceive from this immense distance is a beautiful illusion, masking a reality of wild, majestic chaos that defines the outer atmosphere of this frozen giant. Beneath that serene blue veil lies a world of supersonic winds, forces that move faster than the speed of sound, howling through the darkness in a perpetual dance of atmospheric energy. How can a world so far from the sun, receiving so little solar warmth, generate the most violent winds in the entire solar system? It is a fascinating question that planetary scientists have pondered for decades, revealing that Neptune hides a potent, ancient heat source deep within its core. This internal energy rises slowly outward, colliding with the freezing temperature of open space, creating a dynamic weather system of unmatched power and beauty. The atmosphere is a complex tapestry of hydrogen, helium, and methane, woven together over billions of years into a seamless shroud of gas that glimmers softly in the starlight. As our gaze penetrates deeper through the upper cloud layers, we begin to understand that Neptune is not merely a ball of gas, but a world of dense, exotic states of matter. Deep beneath the outer mists, the immense pressure and temperature transform familiar elements into substances of mythic and terrifying proportions. Scientists believe that thousands of miles beneath the surface, the carbon atoms are squeezed so intensely that they crystallize into literal diamonds, raining down through the mantle like a sparkling, perpetual storm. This hidden ocean of liquid diamond and crystalline rain represents a reality far removed from anything we experience on our home planet, a brilliant secret kept by the giant for eons. It reminds us that nature, under the right cosmic conditions, crafts wonders that surpass the grandest human poetry, hiding them in the darkest corners of space. Let us quiet our thoughts now and allow ourselves to float deeper into this blue sanctuary, exploring the truths that define this magnificent, lonely world at the edge of everything we know. To understand the true isolation of this blue world, we must contemplate the incredible distance it keeps from the heart of our solar system. Neptune drifts nearly 3 billion miles away from the sun, floating in a region of space where the light of our star takes more than 4 hours to arrive. At this vast expanse, the sun appears only as a brilliant spark, stripped of the overwhelming warmth that nurtures life on Earth. This immense separation creates a world shrouded in perpetual dusk, where the heat of creation has faded into a quiet, frozen memory. It is a lonely orbit, a silent trajectory through the outer dark that defines the planet's cold and mysterious character. Because its path around the sun is so incredibly vast, time moves differently in this distant realm compared to our fast-moving inner world. It takes Neptune nearly 165 Earth years to complete just a single revolution around our parent star. This means that since its discovery by human astronomers, the planet has completed only a little over one full journey through its massive orbit. Human generations rise and fall, empires crumble and reform, all while this icy giant makes its slow, deliberate circle through the stars. This epic scale of time invites us to look past our brief moments and appreciate the grand, slow rhythm of the deeper cosmos. The story of how humanity first found this hidden giant is a beautiful testament to the power of human thought and mathematical elegance. Unlike the closer planets that can be seen glittering in the night sky with the naked eye, Neptune was discovered using calculations before it was ever seen through a telescope. Astronomers noticed strange irregularities in the orbit of Uranus, a subtle tugging that suggested another massive body was hiding further out in the dark. By tracking these gravitational ripples, mathematicians precisely predicted exactly where the planet should be hiding in the starry expanse. When observers finally turned their lenses toward that exact spot in the sky, they found the blue world waiting for them, proving that the unseen universe can be mapped by the mind. Despite its great distance and late discovery, Neptune is an absolute titan compared to the rocky world we call home. It spans a diameter nearly 4 times wider than Earth, stretching out across the dark like a vast sapphire sphere. If we could look inside its immense volume, we would find enough space to hold nearly 60 Earths comfortably within its deep, gas-filled interior. Its mass is equally astonishing, carrying 17 times the weight of our own planet, a concentration of heavy elements and dense materials that anchors the outer edge of the system. This scale reminds us of how small and fragile our own planetary cradle is when measured against the giants of the outer void. While its journey around the sun is incredibly slow, the planet spins upon its own axis with surprising and dizzying speed. A single day on Neptune lasts only about 16 hours, a rapid rotation that creates powerful internal dynamics within its deep atmosphere. This swift spinning causes the giant planet to flatten slightly at its poles and bulge at its equator, a distortion shaped by centrifugal force. The rapid movement churns the deep atmospheric layers, driving the powerful currents and weather patterns that define its outer appearance. It is a world of contrast, where the year lasts lifetimes, but the days fly by in a matter of short hours. When we examine the makeup of this distant giant, we discover an atmosphere composed mostly of the simple gases that filled the early universe. Hydrogen and helium dominate the upper layers of the planet, forming a thick, gaseous ocean that wraps around the heavier core beneath. These primordial gases are the very building blocks of stars, Yet here they are held in a deep, frozen embrace by the planet's gravity. As we descend through these outer layers, the density increases smoothly, transitioning from thin gas to a thick, high-pressure mist without ever touching a solid surface. This seamless gradient creates a world without boundaries, a continuous ocean of air that stretches down into the unknown depths. The mesmerizing blue hue that defines Neptune's visual identity is a result of a delicate chemical dance happening within its upper clouds. A trace amount of methane gas is mixed into the dominant hydrogen and helium atmosphere, and this simple molecule changes everything. Methane possesses the unique ability to absorb the red wavelengths of sunlight while reflecting the cool, blue light back into open space. As the faint sunlight filters through the upper mists, the red light is stripped away, leaving only the deep, hypnotic azure to bounce back to our searching eyes. It is a natural filter of cosmic proportions, transforming ordinary starlight into a breathtaking display of deep ocean blue. Much like our own Earth, Neptune tilts gracefully as it spins, giving it a cycle of changing seasons across its vast orbit. Its axis is inclined at an angle of nearly 28 degrees, which is remarkably similar to the tilt that brings spring and summer to our home valleys. However, because its year is so incredibly long, each individual season on Neptune lasts for more than 40 Earth years. Imagine a world where winter remains for half a lifetime, a prolonged period of deep cold where one hemisphere faces away from the distant sun. This slow seasonal shift gently alters the cloud patterns and storm systems, causing subtle changes that play out over decades of human time. Though it is rarely depicted with them, Neptune possesses a delicate and ethereal system of planetary rings encircling its equator. These rings are not bright and reflective like the icy sheets of Saturn, but are instead dark, faint structures composed of dust and organic compounds coated by cosmic radiation. When viewed closely, these rings appear like thin charcoal lines drawn against the black canvas of space, fragile and fleeting. They are divided into distinct tracks, with some sections showing mysterious clumps where material has gathered into thick arcs. These dark bands remind us that even the most distant planets possess a complex, structured environment, a quiet architecture of gravity and dust. For many years, astronomers grouped Neptune together with Jupiter and Saturn as a simple gas giant. But modern science has given it a more precise and accurate title. Today, it is classified as an ice giant, a category it shares with its neighbor Uranus due to its unique internal composition. Unlike the gas giants, which are mostly hydrogen and helium throughout, Neptune holds a massive mantle made of heavier, icy materials like water, ammonia, and methane. These substances are not solid ice like we find on Earth, but exist as a hot, dense, fluid slush under incredible pressure deep beneath the clouds. This distinction places Neptune in a class of its own, a world defined by fluid oceans of heavy molecules hiding beneath an atmospheric veil. Deep within the center of this immense sapphire sphere lies a hidden core made of rock, iron, and cosmic ice. This central heart is estimated to be roughly the same size as our planet Earth, packed tightly by the crushing weight of the layers above. Over billions of years, the heaviest elements sank into this dark interior, creating a dense foundation for the rest of the planet. Temperatures at this core reach thousands of degrees, matching the heat found on the surface of the sun itself. Yet, this intense thermal energy is trapped beneath thousands of miles of high-pressure fluid, leaking outward at a remarkably steady pace. It is a fiery heart resting quietly inside a frozen world, balancing the extreme states of nature in perfect equilibrium. When humanity first sent an automated traveler to photograph this distant giant, scientists discovered a massive storm system known as the Great Dark Spot. This gigantic dark oval was large enough to swallow our entire home planet, a swirling vortex spinning in the southern hemisphere. It represented a colossal high-pressure system, dragging dark materials up from the deeper layers of the atmosphere to create a striking contrast against the lighter blue clouds. Unlike the quiet patterns we might expect from such a cold world, this storm showed that Neptune is incredibly active and alive with motion. It was a majestic emblem of the planet's atmospheric power, turning silently in the dim sunlight at the edge of the system. What surprised astronomers most about this great atmospheric vortex was its fleeting and temporary nature. When space telescopes looked back at Neptune just a few years after the initial encounter, the Great Dark Spot had vanished entirely. Unlike Jupiter's famous storm, which has raged for centuries, Neptune's storms seem to form, evolve, and dissolve over much shorter spans of time. This rapid evolution suggests a highly dynamic environment where atmospheric currents shift and tear apart even the largest weather systems. New dark spots have since appeared in different regions, proving that the planet's face is constantly changing, rewriting its own appearance as the decades pass. Sailing alongside these massive storms, astronomers observed a smaller, fast-moving white cloud affectionately called the Scooter. This bright patch of methane ice crystals zipped around the planet much faster than the larger dark spots, appearing to skip across the cloud tops. Its unusual speed was a result of being embedded in a fast-flowing jet stream that propelled it across the planet's circumference in record time. The crisp, white contrast of this cloud highlighted the complex layering of the atmosphere, showing that different altitudes move at vastly different speeds. It remains a beautiful example of the subtle, smaller features that dance across the giant's face, adding detail to the broad brushstrokes of blue. Further south from the primary storm, another smaller vortex was discovered, often called the Wizard's Eye due to its striking appearance. This feature consisted of a dark core surrounded by a bright ring of white clouds, looking precisely like a solitary eye staring out into the dark void. The white trim was composed of methane ice that formed as air was forced upward and cooled rapidly over the storm's center. This eye-like structure demonstrated that the mechanics of Neptune's weather operate on multiple scales, creating unique shapes across its vast latitudes. It added to the mystique of the planet, presenting a hauntingly beautiful gaze to the cameras that visited it. The winds that whistle through this dark atmosphere hold the undisputed title of the fastest in the entire solar system. At their peak, these supersonic currents can reach speeds of up to 1,200 miles per hour, far surpassing any storm ever recorded on Earth. Such speeds are faster than a modern jet fighter traveling at its maximum velocity, cutting through the thin gas with immense kinetic energy. This violent movement happens in a whisper, since the thin air carries sound differently, making these terrifying winds strangely silent to an outside observer. It is a paradox of nature that the coldest planet possesses the most energetic and sweeping winds known to science. To understand why these winds achieve such terrifying speeds, we must consider the total absence of a solid landscape. On Earth, winds are slowed down by mountains, forests, and oceans, which create friction and disrupt the flow of moving air. Neptune has no such barriers, allowing its atmosphere to slip and slide over itself with almost zero resistance. Once a current of gas gains momentum from the planet's internal heat, there is nothing to stop it, allowing it to accelerate continuously around the globe. This frictionless environment turns the entire planet into a giant, hyper-efficient engine of atmospheric motion, keeping the weather in a state of perpetual acceleration. The driving force behind this magnificent weather is a profound mystery involving the planet's internal heat. Despite sitting in the freezing depths of the outer solar system, Neptune radiates far more warmth into space than it receives from the distant sun. This means the planet has its own internal furnace, a remnant of its formation billions of years ago when gravity packed materials together tightly. As the planet slowly contracts under its own weight, it releases gravitational energy in the form of heat, warming the lower layers from within. This bottom-up heating creates powerful convection currents, where warm gas rises and cold gas sinks, churning the atmosphere into a frenzy. When scientists measured this energy balance precisely, they found that Neptune emits more than 2 times the energy it absorbs from solar radiation. Specifically, it sends about 2.6 times more heat out into the void than the faint sunlight provides to its upper clouds. This makes Neptune significantly warmer than its twin planet Uranus, which sits much closer to the Sun, but has a strangely cold interior. This discrepancy remains one of the great puzzles of planetary science, highlighting how 2 similar worlds can follow completely different paths of internal evolution. It ensures that Neptune remains a dynamic, self-powered engine, maintaining its energetic personality despite its lonely position. All of these incredible details were brought to light by a single, historic robotic mission that visited the planet in the late 20th century. Voyager 2 swept past Neptune in August of 1989, providing humanity with its first and only close-up views of this distant world. The The spacecraft braved the extreme radiation and distance, sending back stunning images of the azure atmosphere, the delicate rings, and the mysterious moons. This brief encounter lasted only a few days before the probe plunged into the interstellar dark, leaving Neptune behind once more. That single archive of data remains our primary window into this giant, a precious gift of knowledge collected by a lonely traveler that continues to drift through the stars. As we float along the outer edges of this blue Titan, we can sense an invisible force stretching far out into the dark void. Neptune possesses a highly unusual and complex magnetic field that behaves quite differently from the fields found on Earth or Jupiter. Instead of aligning neatly with the planet's rotational axis, this magnetic field is tilted at a sharp and dramatic angle of nearly 47 degrees. Furthermore, the center of this magnetic shield does not line up with the physical core of the planet, but is pushed off to the side by thousands of miles. This misalignment creates a wild, asymmetric magnetosphere that wobbles and shifts erratically as the planet spins through the dark. It is an unpredictable shield, weaving an intricate web of invisible energy that captures solar particles in a chaotic dance. To understand why this magnetic shield is so beautifully distorted, we must look at the unique mechanics happening deep within the planet's mantle. On Earth, the magnetic field is generated by the churning action of liquid iron deep within a solid iron core. On Neptune, scientists believe this field originates much closer to the surface, within a vast, swirling ocean of electrically conductive fluid. This ocean consists of water, ammonia, and methane compressed so intensely that the molecules break apart, allowing electrical currents to flow freely. As this thick, ionic slush rotates and churns, it creates a lopsided dynamo that projects the tilted magnetic field out into space. This reminds us that the internal structures of these ice giants operate on entirely different principles than our familiar terrestrial world. Descending deeper into the rich blue atmosphere reveals a subtle yet terrifying reality regarding the physical forces at play. The atmospheric pressure on Neptune increases at an incredible rate. The deeper one travels beneath the upper cloud decks. Near the top of the clouds, the air feels thin and fragile, but a journey of just a few hundred miles downward brings a pressure that would easily crush a modern submarine. There is no sudden boundary or solid ground to stop this descent, only a continuous, thickening fog that grows heavier with every mile. Eventually, the gas is compressed so tightly by the weight above that it behaves more like a hot, dense liquid than a breathable air mass. This extreme environment locks the mysteries of the deep interior away from any probes we might ever dream of sending. Suspended high above the primary cloud layers sits a delicate, ethereal blanket of photochemical haze that softens the planet's appearance. This upper stratospheric mist is created when ultraviolet light from the distant sun strikes the methane molecules in the air, breaking them down into complex hydrocarbons. These tiny, floating particles drift quietly across the globe, acting like a cosmic veil that filters the incoming starlight before it reaches the deeper clouds. This haze layer is not uniform, but shifts and aggregates into subtle bands that alter how the planet reflects the light of distant stars. It creates a soft, glowing halo around the edge of the blue disk, adding a layer of visual texture to the deep sapphire world below. It is a quiet testament to the gentle chemical reactions that can occur even in the freezing, sun-starved outer reaches of space. Within this high-altitude haze, planetary scientists have discovered a fascinating paradox involving the temperature of Neptune's upper atmosphere. One would naturally expect that the further away you move from the planet's internal heat, the colder the environment would become. Yet, the stratosphere of Neptune experiences a surprising warming effect, where temperatures actually rise at higher altitudes. This unexpected warmth is caused by those very hydrocarbon gases, such as ethane and acetylene, which absorb the faint solar energy and trap it effectively. This creates a delicate thermal layer that rests quietly above the freezing troposphere, a warm blanket of thin gas suspended in the open dark. It shows us that even in a world defined by extreme cold, nature finds a way to create complex, layered ecosystems of heat and energy. Despite the massive scale of this giant world, a traveler standing on its imaginary surface would experience a surprisingly familiar pull of gravity. Because Neptune is composed primarily of lightweight gases and icy fluids, its overall density is much lower than that of the rocky Earth. When you calculate the gravitational pull at the cloud tops, it is only about 14% stronger than the gravity we feel under our own feet every day. If it were possible to float calmly upon these blue clouds, you would hardly notice the difference in your weight, moving with a familiar ease. This balancing act between immense cosmic volume and low physical density creates a gentle gravitational environment for such a massive Titan. It serves as a beautiful reminder that cosmic size does not always translate into overwhelming, crushing power at the outer boundaries. Let us look deeper now into one of the most mesmerizing secrets hidden within the mantle of this majestic ice giant. Deep within the mid-layers of the planet, where the temperature rises to thousands of degrees, the intense pressure begins to tear methane molecules apart. The hydrogen atoms are stripped away, leaving pure carbon atoms suspended in a hot, dense environment that forces them to bind together. Under these extreme conditions, the carbon atoms organize themselves into flawless, crystalline structures that we would instantly recognize as diamonds. These heavy gemstones, forming continuously in the dark, begin a slow and silent descent through the fluid layers of the mantle. It is a literal rain of precious stones, a glittering shower of cosmic wealth falling through the interior of a lonely world for billions of years. As these diamonds sink further into the extreme depths, scientists hypothesize that an even more fantastical landscape begins to take shape. Near the boundary of the rocky core, the temperature and pressure become so overwhelming that even these diamonds may begin to melt into a liquid state. This could create a vast, shimmering ocean of liquid carbon, a fluid mirror reflecting the immense energies of the planet's deepest interior. Floating upon this unique ocean could be massive blocks of solid diamond, acting like crystalline icebergs drifting through a sea of liquid gem. This hidden landscape remains completely obscured from our sight, locked away in a realm where physics behaves like magic. It challenges our understanding of geology and forces us to imagine worlds where the rarest terrestrial treasures are merely basic building blocks. For many years, the distinct difference in color between Neptune and its near twin Uranus remained a captivating mystery for observers. Uranus appears as a pale, washed-out cyan, while Neptune boasts a rich, deep royal blue that commands attention. Recent breakthroughs in planetary modeling suggest that this difference is caused by the thickness of the atmospheric haze layers wrapping each planet. Uranus possesses a much thicker, stagnant layer of white methane haze that reflects a great deal of white light, diluting its underlying color. Neptune, with its energetic internal heat source, actively churns its atmosphere, causing this haze to clear out and precipitate downward more efficiently. This leaves a cleaner, more transparent upper atmosphere that allows the deep blue color of the methane gas to shine through with breathtaking clarity. Despite the internal fires that drive its supersonic winds and melt diamonds, the outer face of Neptune remains a place of unimaginable, bone-chilling cold. At the very top of the cloud layers, temperatures plunge to nearly 370 degrees below zero on the Fahrenheit scale. This extreme temperature is close to absolute zero, the theoretical point where all molecular motion ceases entirely. At these freezing depths, gases that are volatile on Earth freeze instantly into delicate crystalline frosts that drift through the thin air. This outer layer of frost acts as a quiet shield, keeping the energetic secrets of the planet's warm interior safely hidden from the frozen void of space. It creates a stunning juxtaposition, where a shell of absolute winter guards a heart of roaring warmth and perpetual motion. Neptune is not a solitary wanderer in the deep dark, for it commands a court of 14 known moons, each a small fragment of cosmic history trapped in its frozen grasp. The largest of these companions is Triton, a spectacular and massive world discovered just 17 days after Neptune itself was first spotted by human eyes. This rapid discovery showed that even the most distant planets possess intricate subsystems that mirror the structure of the larger solar family. Triton is so exceptionally large that it contains more than 99% of all the mass currently orbiting the ice giant, completely dominating its lunar family. It drifts through the darkness as a frozen world of ice and rock, keeping a watchful, permanent vigil over its deep blue master. This lopsided distribution of mass leaves the other 13 moons as mere remnants, small rocky bodies that fade into the background of Triton's immense presence. When astronomers began to trace the path of Triton across the velvet sky, they discovered a stunning anomaly that challenged their understanding of planetary formation. Triton revolves around Neptune in a retrograde orbit, meaning it moves in the opposite direction of the planet's own rotation. This backward journey is completely unique among the large moons of our solar system, serving as a glaring cosmic signature of a dramatic and violent past. Such an unusual orbit proves that Triton did not form from the same swirling disk of dust that birthed Neptune billions of years ago. Instead, it must have been an independent traveler, a lonely wanderer sailing through the dark outer reaches before being trapped by the giant's gravity. This reverse motion creates a continuous gravitational tension between the moon and the planet, shaping a relationship unlike any other in the system. The true origin of this backward-spinning moon is believed to lie in the vast and icy graveyard of the Kuiper Belt, far beyond the orbit of Neptune. Billions of years ago, Triton likely existed as an independent dwarf planet, much like Pluto, drifting peacefully through the frozen remnants of the early solar system. As its path brought it too close to the immense gravitational influence of the ice giant, the planet's gravity acted as an invisible net, snaring the traveler and forcing it into a permanent embrace. This ancient capture must have triggered an era of chaotic tidal heating, melting Triton's interior and reshaping its surface into a canvas of smooth plains and jagged fractures. Today, it stands as a captured relic of the deep wilderness, a pristine piece of the outer edge brought close for us to observe and admire. This celestial adoption permanently altered the structure of Neptune's entire satellite system, clearing out or destroying any original moons that stood in Triton's way. This ancient gravitational capture established a tragic destiny for the massive moon, one that will play out over hundreds of millions of years in the silent dark. Because Triton moves in a retrograde direction, the tidal forces between the moon and Neptune act as a continuous, gentle brake on its orbital speed. With each passing century, Triton loses a tiny fraction of its orbital energy, causing its path to decay and spiral slowly closer to the sapphire clouds below. Eventually, after countless ages have passed, the moon will cross an invisible boundary known as the Roche limit, where Neptune's immense gravity will overcome the internal forces holding Triton together. The moon will be violently torn apart, its icy remains shattering into billions of glittering fragments that will spread out to form a majestic, brilliant ring system, rivaling that of Saturn. This eventual transformation reminds us that even the grandest structures in the cosmos are temporary, slowly evolving into new forms of beauty. Despite the extreme cold that grips the surface of Triton, this captured world is far from dead, surprising scientists with signs of active geology at the edge of the system. Voyager 2 captured stunning images of massive geysers erupting from the frozen crust, sending plumes of dark material high into the thin nitrogen atmosphere. These cryovolcanoes do not spew molten rock, but instead blast out a freezing mixture of liquid nitrogen, dust, and methane ice from deep underground reservoirs. The dark plumes rise up to 5 miles into the sky before being caught by the faint lunar breezes, stretching out into long, horizontal streaks across the icy plains. This active plumbing system shows that even the coldest moons can maintain an internal heat engine, driven by radioactive decay and ancient tidal forces. It challenges our assumptions about the outer solar system, proving that geological activity can thrive in environments far removed from the warmth of the sun. The surface of Triton is a bizarre alien landscape covered in a glittering blanket of frozen nitrogen, water, and carbon dioxide ice that looks like a dreamscape. This icy crust reflects the faint sunlight with an intense, pale brilliance, making the moon one of the brightest and most reflective objects in the outer solar system. In certain regions, the terrain takes on a unique and highly textured appearance that scientists call the cantaloupe terrain due to its resemblance to the wrinkled skin of a melon. This strange texture is formed by the slow deformation and rising of low-density ice through the heavier crust, a process similar to the movement of salt domes on Earth. Walking upon this frozen world would reveal an endless expanse of pale pink and blue hills, sculpted by cosmic forces over eons of isolation. It is a quiet, frozen gallery of natural art, preserved perfectly by the absolute cold of the open void. Returning our thoughts to the deep blue atmosphere of Neptune itself, modern telescopes have detected a chemical component that adds a unique sensory detail to the clouds. Deep within the upper cloud decks, scientists have confirmed the presence of hydrogen sulfide, a gas composed of hydrogen and sulfur atoms. On Earth, this specific compound is infamous for its highly pungent aroma, closely resembling the scent of rotten eggs or volcanic vents. If an explorer could somehow survive the freezing cold and crushing pressure to breathe the air, the planet would possess an incredibly sharp and unwelcoming smell. This gas condenses into delicate white clouds of sulfide ice that float beneath the higher methane mists, contributing to the complex, multi-layered weather structure of the giant. It is a striking reminder that the beautiful, serene colors of distant worlds can mask chemical realities that are harsh and alien to human senses. The faint and dusty rings that encircle the equator of Neptune are not uniform bands, but are divided into distinct structures named after the pioneers who unraveled the planet's mysteries. The innermost ring is named Gala, honoring the German astronomer who was the first to physically see the planet through a telescope lens. Further out lies the Leverrier ring, celebrating the French mathematician whose calculations pointed the way to the hidden world in the dark. The outermost and most substantial ring bears the name of Adams, the English mathematician who independently calculated the planet's position at the same time. These dark bands of dust serve as permanent monuments etched into the sky, celebrating the human intellect that reached across billions of miles to find a world hidden in darkness. They remind us that our journey into the cosmos is guided by the minds of those who dared to look closely at the anomalies of the universe. Within the outermost Adam's ring, astronomers discovered a phenomenon that seemed to defy the standard laws of orbital mechanics and physics. Instead of spreading out evenly around the planet, the material in this ring is concentrated into 5 dense, bright clumps known as ring arcs. These arcs are named after the fundamental ideals of the French nation, representing liberty, equality, fraternity, and courage, along with a smaller companion arc. Normally, the dust particles in a ring should distribute themselves smoothly over time due to constant collisions and orbital motion, dissolving any clumps. The persistence of these arcs suggests that a hidden mechanism is actively clustering the particles together and preventing them from scattering into a uniform band. It represents a beautiful mystery where dust behaves like a structured collective, holding its shape against the tendency of the universe to scatter everything into chaos. The celestial guardian responsible for maintaining these mysterious ring arcs is a tiny, dark moon named Galatea, which orbits just inside the Adam's ring. As Galatea circles the planet, its gravitational field creates subtle ripples and waves in the path of the nearby ring material. This gravitational interaction acts like an invisible broom, sweeping the dust particles into specific, stable pockets and keeping them locked in place. The energy exchanged between the moon and the ring particles ensures that the arcs maintain their sharp definition despite the constant motion of the system. It is a beautiful display of cosmic choreography, where a minor moon and a collection of cosmic dust dance in perfect harmony to preserve a delicate structure at the edge of the void. This relationship highlights the invisible threads of gravity that bind the components of the solar system together, creating order out of wandering dust. Beyond Triton, the inner court of Neptune contains a world known as Proteus, a massive chunk of dark rock that holds a unique place in planetary science. Proteus is the second largest moon in the Neptunian system, yet it remained hidden from human eyes until Voyager 2 swept past its dark silhouette. It is so close to the planet and so dark that telescopes on Earth could never distinguish its faint reflection from the overwhelming glare of the sapphire giant. What makes Proteus truly fascinating is its irregular, boxy shape, appearing like a fractured cosmic gemstone covered in deep craters. Scientists discovered that Proteus is at the absolute limit of how large a planetary body can grow without its own gravity, pulling it into a perfect sphere. It rests in a state of perpetual geological suspension, a giant fragment of the early solar system preserved in the deep cold. Much further out in the cold darkness, we encounter Nereid, a moon that follows one of the most eccentric and elongated paths in the entire solar system. Instead of circling the planet in a neat, orderly line, Nereid swings wildly from being relatively close to Neptune to drifting millions of miles away into the open void. This extreme orbit means that it takes nearly a full Earth year for this small moon to complete just one journey around its blue master. Such a chaotic and stretched trajectory strongly suggests that Nereid was profoundly disrupted during the ancient times when Triton was captured by Neptune's gravity. It was cast out into the orbital wilderness, forced into a permanent roller coaster ride across the outer edge of the planetary system. This lonely moon serves as a silent witness to the violent cosmic rearrangement that reshaped this entire region of space billions of years ago. The immense gravitational reach of Neptune extends far beyond its own moons, shaping the destinies of objects that reside in the wider Kuiper belt. A beautiful example of this cosmic architecture is the permanent relationship between Neptune and the dwarf planet Pluto. Even though their paths actually cross each other in space, these two worlds are locked in a perfect mathematical dance that prevents them from ever colliding. For every 3 trips Neptune makes around the Sun, Pluto completes exactly 2, an orbital resonance that has held steady for billions of years. This precise timing ensures that whenever Pluto approaches the crossing point, Neptune is always far away on the other side of the solar system. This unseen gravitational harmony organizes the outer darkness, turning a potential cosmic disaster into a timeless display of celestial clockwork. As Neptune journeys through its immense orbit, it does not travel alone, but is accompanied by a hidden convoy of ancient space rocks known as Trojan asteroids. These primitive bodies are trapped in stable gravitational pockets located 60 degrees ahead of and 60 degrees behind the planet along its orbital path. These regions, known as Lagrange points, act like celestial nets, holding the asteroids in a permanent lockstep with the giant planet. Scientists believe that these hidden companions may number in the thousands, representing a vast repository of material left over from the dawn of creation. Traveling together through the dark, this silent fleet shares the planet's long, 165-year journey around the distant sun. They remind us that even the most isolated planets are part of a larger, interconnected web of gravity and matter that spans the cosmos. To understand why Neptune resides so far out in the frozen wilderness, we must look back at modern theories of how our solar system grew and changed in its infancy. Grand computer models suggest that the ice giant did not actually form in its current, lonely position nearly 3 billion miles from the Sun. Instead, Neptune was birthed much closer to the inner system, right alongside Jupiter, Saturn, and Uranus, where material was dense and plentiful. Over hundreds of millions of years, the gravitational tussle between the giant gas planets created a massive orbital instability that pushed the outer worlds outward. Neptune was cast the furthest into the dark, plowing through the early Kuiper belt and scattering billions of icy comets into the deep void. This ancient journey of planetary migration completely rewrote the map of our solar system, leaving Neptune as the permanent sentinel at the outer gate. Deep within the innermost ring structures of the planet, two tiny moons named Naiad and Thalassa perform a stunning orbital dance of avoidance. These small, dark worlds orbit so close to one another that their gravitational fields should naturally destabilize their paths over time. To survive this close companionship, Naiad moves in an unusual, wavy trajectory that loops up and down relative to Thalassa's more even path. Every time Naiad passes its companion moon, it is either safely above it or safely below it, creating a rhythmic, zigzag pattern across the sky. This intricate choreography keeps them separated by a comfortable margin, preventing a destructive collision in the crowded inner system. It is a miniature masterpiece of orbital mechanics, a delicate ballet performed in the dark, where survival depends on perfect timing and symmetry. At this immense distance from the center of the solar system, the physical nature of starlight undergoes a profound transformation that alters our perception of space. The sunlight that reaches the clouds of Neptune is roughly 900 times fainter than the bright warmth that illuminates the surface of Earth. To an explorer floating in the upper atmosphere, the noonday sun would appear as a tiny, piercing disk of light that provides no perceptible heat to the skin. Despite this extreme dimness, the human eye would still perceive the landscape as surprisingly bright, comparable to a gloomy, overcast day on our home planet. This faint illumination is still powerful enough to drive the chemical reactions that create the high-altitude haze we observed earlier. It is a quiet reminder that even a heavily diluted spark of solar energy can leave a lasting imprint on a giant world at the edge of the dark. Looking past the intermediate moons, we discover a pair of ultra-distant satellites named Niso and Samathe that push the boundaries of what it means to orbit a planet. These tiny, irregular fragments of rock travel on paths that take them more than 30 million miles away from the blue giant. Their orbits are so incredibly vast that it takes these two moons more than 25 Earth years to complete just one single revolution around Neptune. From such a staggering distance, Neptune appears only as a prominent blue dot in their sky, barely distinguishable from the surrounding stars. These worlds drift on the absolute edge of Neptune's gravitational domain, where the gentle pull of the sun constantly threatens to tear them away into open interstellar space. They represent the extreme outer fringe of the satellite family, lingering in a silent twilight where the line between planet and open void dissolves completely. The immense gravitational dominance that Neptune displays over these distant moons and asteroids is the key reason it earned its status as a true planet. According to modern astronomical definitions, a celestial body must be massive enough to clear its orbital neighborhood of any competing objects. Neptune has thoroughly achieved this over its long history, using its massive gravity to either swallow, capture, or fling away any debris that crossed its path. Even though the vast wilderness of the Kuiper Belt lies just beyond its orbit, Neptune remains the undisputed master of its own specific lane through the cosmos. Any object that enters this zone is immediately subjected to the planet's powerful gravitational laws, forced into a stable resonance, or cast out entirely. This absolute authority cements its role as one of the 8 true guardians of our solar system, a sovereign world ruling over an enormous expanse of dark space. The poetic tradition of naming this distant world after Neptune, the ancient Roman god of the deep sea, fits its physical reality with astonishing perfection. When astronomers chose this name in the 19th century, they had no idea that the planet possessed a rich, oceanic blue color or a mantle filled with fluid water and ammonia slush. The naming convention extended beautifully to its moons, which are traditionally named after lesser sea deities, nymphs, and ocean spirits from ancient mythology. This creates a cohesive narrative across the entire system, transforming a collection of cold data points into a majestic, mythological kingdom in the sky. As we contemplate these naming choices, we see a beautiful bridge between human imagination and the grand realities of astrophysics. It allows us to view this icy giant not just as a cold ball of gas, but as a grand, poetic sanctuary resting quietly at the edge of the eternal dark. Deep inside the mantle of the ice giant, water behaves in ways that completely challenge our traditional understanding of states of matter. Under the immense pressure of the upper atmosphere, water molecules are squeezed so tightly that they enter a phase known to physicists as supersonic ice. In this exotic state, the oxygen atoms lock into a solid crystalline framework, while the hydrogen atoms melt into a fluid that flows freely through the grid like an electric current. This makes the material simultaneously a solid and a liquid, possessing an incredible capacity to conduct electricity and heat across the interior. It is this unique substance that helps generate the distorted magnetic field we observe from the outside, shifting and swirling beneath the blue clouds. Such bizarre states of matter remind us that the interiors of distant worlds are laboratories of physics operating far beyond the limits of everyday experience. When we map the movement of the clouds across the vast expanse of the planet, we find that Neptune does not rotate as a single, rigid body. The wind systems at the equator blow in the opposite direction of the planet's internal rotation, lagging behind the deeper core by hundreds of miles per hour. Meanwhile, the gas at the higher latitudes near the poles moves in the same direction as the core, completing a rotation much faster than the equatorial bands. This phenomenon, known as differential rotation, tears at the borders between the atmospheric zones, creating endless turbulence and friction. The planet is essentially shearing itself apart from the inside out, with different layers of gas sliding past each other at varying speeds. This continuous atmospheric friction generates immense kinetic energy, fueling the persistent storms that wander across the sapphire landscape. High above the deep royal blue decks of the main atmosphere, delicate white streamers of methane ice crystals catch the faint starlight. These high-altitude clouds are the cirrus formations of the outer solar system, condensed from rising pockets of methane gas that freeze instantly in the stratosphere. Because they float dozens of miles above the main cloud deck, they cast distinct, dark shadows onto the blue floor below them. Observing these shadows allowed planetary scientists to calculate the exact altitude and thickness of these ghostly white ribbons from billions of miles away. They appear and disappear in a matter of hours, a fleeting network of icy threads spun by the energetic winds of the upper atmosphere. This three-dimensional cloud structure transforms the face of the planet into a living, shifting canvas of light and shadow. While our single close-up view came from a passing mechanical traveler long ago, humanity has continued to watch this blue world using powerful eyes stationed near Earth. The Hubble Space Telescope and the James Webb Space Telescope have provided decades of continuous observations, capturing the planet in wavelengths of light invisible to the human eye. In the infrared spectrum, Neptune ceases to look like a quiet blue sphere and instead glows with intense thermal energy from its active weather systems. The high-altitude clouds shine brightly against the dark disk, revealing the secret currents of heat rising from the deep interior. These space-based observers allow us to witness the long-term evolution of the planet's climate, tracking how whole storm systems form and dissolve across the decades. They show us that even from the comfort of Earth's orbit, we can touch the pulse of a world at the edge of the system. A recent and astonishing discovery revealed that the weather on Neptune is intimately connected to the activity of the distant sun, despite the immense gap of space between them. Astronomers analyzing decades of planetary data noticed that the abundance of white clouds on Neptune ebbs and flows in a regular 11-year cycle. This pattern aligns perfectly with the solar cycle, where the sun increases and decreases its output of intense ultraviolet radiation. When the sun is active, the extra ultraviolet light triggers chemical reactions in Neptune's upper atmosphere, causing bright methane clouds to bloom across the planet. When the solar activity fades, the clouds slowly dissolve back into the blue mist, leaving the planet looking unusually clear and dark. This cosmic connection demonstrates that the hand of our parent star still shapes the environment of its furthest child, weaving its influence across billions of miles of silent void. By analyzing the precise chemical signature of the gases floating in the outer atmosphere, scientists can look backward through time to the very birth of our planetary system. The ratio of heavy hydrogen, known as deuterium, to regular hydrogen on Neptune provides a pristine record of the materials that existed in the early solar nebula. Because Neptune is so cold and distant, it has preserved these ancient gases in a deep freeze, unchanged by the intense heat or solar winds that stripped the inner worlds. The high concentration of deuterium found there matches the composition of primitive comets, proving that the ice giant built itself from the same ancient icy debris. This chemical fingerprint allows astrobiologists and astronomers to reconstruct the recipe of the primordial cloud that collapsed to form the sun and the planets. It turns the giant blue ball into a cosmic time capsule, holding the elemental secrets of our ultimate origins safely in its icy treasury. As the lopsided magnetic field of Neptune wobbles through space, it interacts with the thin stream of charged particles blowing outward from the sun. This solar wind, heavily diluted by its long journey to the outer system, encounters a magnetosphere that opens and closes like a complex celestial gate. Because the magnetic axis is tilted so sharply, the planet rotates through the solar wind with its magnetic poles pointing alternately toward and away from the incoming stream. This creates a highly dynamic and chaotic magnetospheric boundary, where solar particles are constantly trapped, accelerated, and flung away in erratic patterns. The resulting aurorae, though faint and difficult to see from Earth, ripple quietly across the upper atmosphere in infrared light. It is an invisible light show powered by the struggle between a dying solar breeze and a spinning magnetic Titan. Despite the immense gravity that holds Neptune's thick atmosphere together, the planet is slowly and continuously losing a tiny fraction of its gas to the open void. Light atoms of hydrogen and helium at the very edge of the exosphere occasionally gain enough energy to break free from the planet's gravitational pull, drifting out into interstellar space. This slow leakage is a common fate for all planets, yet Neptune maintains a remarkably stable atmospheric density over billions of years. The loss of gas at the top is perfectly balanced by the continuous release of volatile materials from the warm, churning mantle deep below. As the internal heat pushes new gases upward, the atmosphere is constantly replenished from within, a self-sustaining system that resists the stripping power of the vacuum. This delicate balance ensures that the blue giant will retain its thick, protective shroud for trillions of years to come. When we contrast Neptune with its closer neighbor Uranus, we are forced to confront a profound mystery regarding planetary evolution and internal structures. These two worlds are nearly identical in size, mass, and chemical composition, yet their personalities are entirely different. Uranus is a quiet, sluggish world with almost no internal heat and very few visible cloud features, resting on its side in a state of atmospheric stagnation. Neptune, on the other hand, is a roaring engine of weather, driven by its warm heart to create supersonic winds and spectacular storm systems. Some scientists believe that a cataclysmic collision in the ancient past stripped Uranus of its primordial heat, while Neptune was spared such a fate, allowing its internal furnace to remain intact. This comparison shows us that even twin worlds can follow radically different paths, reminding us that every object in the cosmos has its own unique biography written in the dark. The current architecture of the outer solar system is a direct result of Neptune's massive gravitational cleanup operation that lasted for hundreds of millions of years. During its ancient outward migration, the planet acted like a celestial snowplow, carving a wide, clean path through the dense disk of icy planetesimals that once filled this region. Billions of these icy rocks were slung inward toward the sun or flung completely out into the interstellar wilderness, emptying the space around the giant's orbit. The objects that survived this sweep were forced into stable gravitational pockets or locked into precise orbital resonances, much like Pluto and the Trojan asteroids we explored earlier. This thorough clearing of its neighborhood is what defines Neptune as a true sovereign planet, an ordering force that transformed a chaotic ring of debris into a structured, peaceful frontier. It leaves the planet as the final, magnificent monument of order before the true lawlessness of the deep interstellar void begins. As we let our minds linger near the dark rings of Neptune, we begin to realize how structurally different they are from the brilliant ice sheets surrounding Saturn. Instead of being composed of large, reflective chunks of clean water ice, these dark structures are made almost entirely of fine, microscopic dust particles. This dust is incredibly tiny, with many particles being no larger than the individual grains found in a cloud of smoke on Earth. Scientists believe these rings are primarily composed of dark carbon-based compounds and silicates that have been darkened over eons by intense cosmic radiation. Because these particles are so lightweight, they are highly sensitive to the subtle pressures of starlight and the magnetic fields of the giant planet. They drift in a quiet, fragile suspension, forming a ghostly network of dark lanes that wrap around the equator like a silken ribbon of shadow. Sailing slightly inward from the outer ring arcs, we encounter a small and deeply hidden moon named Despina, another quiet keeper of the planet's ring system. This tiny, irregularly shaped world orbits incredibly close to the blue giant, completing a full circle around the planet in just over 8 hours. As it zips through the inner system, its gentle gravity interacts directly with the nearby Leverrier ring, acting as a protective shepherd that guides the wandering dust particles. Without the continuous stabilizing presence of Despina, the fine material of this ring would slowly spread out and dissipate into the open void of space. The moon leaves a subtle gravitational wake behind it as it travels, creating beautiful, invisible ripples in the sea of dust it guards so faithfully. It stands as a perfect example of how small, unnoticed bodies can maintain the structural order of an entire planetary environment through the silent threads of gravity. The architectural complexity of this ring system extends even further to include the faint, broad bands known as the Lassell ring and the Arago ring. The Lassell ring is a wide sheet of dim material that stretches out between the inner Leverrier ring and the outer Adams ring, forming a subtle floor of dust. At its outer edge sits the narrow, concentrated Arago ring, a sharp line of material named after the French astronomer who championed the search for Neptune. These structures are so thin and emit so little light that they appear completely invisible to all but the most sensitive spacecraft instruments. They remind us that what appears to be empty space from a distance is often filled with a quiet, structured geometry of matter. Floating through these dim pathways allows us to appreciate the intricate layering of the cosmos, where even the faintest structures follow precise mathematical laws. To confirm the fantastic theory of diamond rain falling through the planet's interior, scientists on Earth have turned to advanced laboratories to recreate these alien conditions. Using incredibly powerful lasers and specialized compression devices known as diamond anvil cells, researchers have subjected simple plastics to extreme pressures and temperatures. Under these intense conditions, which mimic the mid-layers of Neptune's mantle, the carbon atoms inside the plastic instantly separated and formed tiny nanodiamonds. This successful replication proved that the physics of carbon separation is an absolute reality under the crushing weight of an ice giant's atmosphere. It bridges the gap between human laboratory science and the majestic mysteries of the outer solar system, showing that the laws of nature remain constant across the void. This scientific pursuit reminds us that even the most distant and inaccessible corners of the cosmos can be understood through patience and ingenuity. If a robotic probe were designed to descend directly into the heart of Neptune, it would never encounter a dramatic moment of impact with a solid ground. Instead, the descent would be a continuous, seamless transition where the boundary between atmosphere and ocean becomes completely blurred. As the probe moved deeper through the increasing pressure, the hydrogen and helium gases would gradually transform into a dense, supercritical state. In this exotic physical phase, the material exhibits the properties of both a gas and a liquid simultaneously, moving with fluid ease, yet filling the space completely. This means the planet is essentially an endless, bottomless ocean of hot, compressed fluids that gradually grows thicker and hotter the further down one travels. It is an environment that defies our basic earthly intuition of solid ground and open air, presenting a world of continuous, fluid unity. In the modern era of space exploration, astronomers utilizing the Hubble Space Telescope made a surprising discovery by identifying a 14th moon named Hippocamp in the year 2013. This tiny world is the smallest of Neptune's inner satellites, measuring only about 20 miles across as it drifts through the dark. What makes Hippocamp particularly fascinating is its close proximity to the much larger moon Proteus, which travels along an almost identical orbital path just a short distance away. Scientists hypothesize that Hippocamp is actually an ancient fragment of Proteus, chipped off billions of years ago during a colossal impact with a wandering comet. This tiny satellite serves as a floating scar of an ancient celestial collision, preserved perfectly in the quiet orbital tracks of the inner system. It illustrates that the moon systems of the ice giants are not static, but are living histories shaped by the violent currents of cosmic time. When we observe the churning atmosphere of Neptune with high-definition imaging, we notice that the sapphire backdrop is broken by a rich variety of cloud colors, while the high cirrus clouds shine with a brilliant, snowy whiteness due to reflected starlight on methane crystals. Other storm features appear in shades of deep slate gray or dark blue. These subtle color variations are caused by differing concentrations of complex trace gases and hydrocarbons that are dredged up from the deep interior by powerful convection currents. As these materials rise into the cold upper atmosphere, they undergo photochemical changes that alter how they interact with the faint sunlight. This creates a beautifully complex, multicolored tapestry where the local chemistry of each individual storm dictates its visual appearance against the broader blue canvas. This gentle shifting of shades adds a deep, three-dimensional texture to the planet's appearance, turning a simple sphere into an intricate work of cosmic art. The reason the rings of Neptune remained hidden from human knowledge for so long is due to their exceptionally low albedo, or reflective power. These dusty bands reflect only about the same tiny fraction of light as a fresh block of charcoal or asphalt on Earth. When faint sunlight strikes these dark particles, almost all of the energy is absorbed rather than bounced back into space, leaving them shrouded in deep shadow. This low reflectivity requires astronomers to use specialized infrared sensors that look for the faint heat signatures of the dust rather than visible light. It stands as a beautiful reminder that much of the true structure of our universe is painted in shades of deep black, requiring us to expand our vision beyond the narrow limits of human sight to see the full picture. As we contemplate these hidden bands of dust, we realize that the dark wilderness is filled with quiet, invisible structures waiting to be discovered. The immense physical mass of Neptune creates a powerful gravitational well that is measured by its exceptionally high escape velocity. To break free from the planet's gravitational embrace at the level of the cloud tops, an object would need to travel at a speed of more than 23 kilometers per second. This immense speed is far greater than the escape velocity of Earth, reflecting the deep, massive pull that the ice giant exerts on everything around it. This powerful gravitational grip is the precise reason the planet can hold onto its vast atmosphere of lightweight hydrogen and helium gases over billions of years, without them leaking away completely into the vacuum. It acts like an invisible, heavy anchor that secures the planetary material in place, ensuring that the giant retains its majestic form against the eroding forces of open space. It stands as a testament to the quiet, unyielding strength of this distant Titan, a force that commands the space around it with absolute authority. Following the chaotic eras of ancient planetary migration, the orbit of Neptune has settled into a state of profound and beautiful long-term stability. Today, the planet acts as a steady gravitational anchor for the inner edge of the entire Kuiper belt, organizing the paths of thousands of icy bodies that reside in the outer wilderness. Its regular, predictable journey through space creates a protective boundary that shields the inner solar system from an overwhelming influx of wandering comets. This majestic stability shows that the violent conflicts of the early solar system eventually give way to a state of quiet, balanced harmony that can last for trillions of years. As we watch this blue sentinel make its slow, deliberate circle through the dark, we can appreciate the deep peace that comes when the storms of creation finally settle into a permanent, cosmic order. This enduring equilibrium invites us to reflect on the grand, patient rhythms of the deeper cosmos, where time washes away all chaos. Long before the mathematical triumphs of the 19th century, a famous Italian observer unknowingly caught a glimpse of this distant blue treasure. Galileo Galilei turned his primitive telescope toward the stars in the early 17th century and recorded the position of Neptune. Yet he cataloged it merely as a faint, motionless star. Because the planet moves so slowly through its massive orbit, its position relative to the background stars changed by only a microscopic fraction during his brief days of observation. This historic oversight remained hidden in his notebooks for centuries, a silent proof that the giant had been seen, but not truly found by human intellect. It invites us to ponder how many wonders of the cosmos drift quietly before our eyes, waiting for the right moment and the right tools to be truly understood. It shows that Neptune was patiently waiting at the edge of our vision, a quiet secret hiding in plain sight for generations. Among the inner court of small satellites, the moon Larissa follows a trajectory that highlights the fragile balance of orbital mechanics. This irregular, cratered world drifts so close to the upper atmosphere of Neptune that it travels faster than the planet itself rotates on its axis. Because of this extreme proximity, tidal forces are continuously robbing Larissa of its orbital energy, causing its path to sink slowly toward the blue clouds with every revolution. Scientists calculate that this tiny moon is doomed to a violent end, eventually breaking apart to form another dark ring or plunging directly into the supercritical mists below. This slow inward spiral contrasts beautifully with the outward movement of our own Earth's moon, reminding us that gravity can be a gentle tether or a slow, inevitable trap. It presents a haunting picture of a tiny world counting down its final cosmic eras in the silent shadow of its master. The lopsided rotation and severe tilt of the planet's magnetic field create an invisible structure in space known as a twisted magnetotail. As the solar wind flows past Neptune, the asymmetrical magnetic shield rotates like a giant, wobbling top, braiding the invisible lines of force behind it. This interaction sculpts the magnetotail into a complex, corkscrew shape that stretches out for millions of miles into the deep interstellar void. This massive magnetic wake acts like a swirling vortex of energy, trapping charged particles in an intricate, three-dimensional geometry that shifts constantly with the planet's 16-hour day. It is an extraordinary departure from the straight, streamlined magnetic tails of other planets, showing how unique rotation can reshape the local vacuum. Floating through this invisible tapestry would reveal a realm of shifting magnetic currents, a silent symphony of plasma dancing to the rhythm of the spinning giant. When modern spectroscopes analyze the chemical makeup of Neptune's upper atmosphere, they find faint traces of carbon monoxide and hydrogen cyanide gases resting in the stratosphere. These specific chemical compounds should not naturally exist in the cold upper layers, as they would normally be destroyed by ultraviolet light or washed down into the deeper mantle. Their persistent presence suggests that Neptune was struck by a massive, icy comet in the relatively recent cosmic past, an event that injected these volatile elements high into the atmosphere. This ancient impact left a permanent chemical scar that has spent centuries spreading smoothly across the entire globe, carried by the supersonic winds. It transforms the thin air of the planet into an archival record of external visitations, showing that even the most isolated worlds are deeply connected to the wandering debris of the wider universe. It allows us to view the quiet atmosphere as a canvas where the history of cosmic collisions is written in delicate molecules. A fascinating climate anomaly occurs at the southern pole of Neptune, where astronomers have detected a localized region of unexpected warmth. Because the planet's long seasons last for decades, the South Pole has been tilted continuously toward the faint light of the distant sun for more than 40 Earth years. This prolonged exposure, though faint, has warmed the polar atmosphere by about 20 degrees compared to the rest of the freezing globe. This subtle temperature difference creates a high-altitude polar vortex, a swirling cap of gas where methane remains volatile enough to escape being frozen into white crystals. It leaves the pole looking uniquely clear and dark, a warm window looking down into the deeper, energetic layers of the sapphire atmosphere. This polar furnace shows how even a heavily diluted sun can sculpt the long-term weather patterns of an ice giant, creating localized sanctuaries of warmth in an ocean of absolute winter. The historic encounter with Voyager 2 required an exceptional display of trajectory design, utilizing the gravity of Neptune as a cosmic slingshot. To closely examine the massive moon Triton and its mysterious nitrogen geysers, the spacecraft was directed to pass just thousands of miles above Neptune's north pole. This precise path used the planet's immense physical mass to violently bend the probe's trajectory downward, changing its course forever. This maneuver sent Voyager 2 plunging sharply out of the flat plane, where all the planets reside, directing it on a permanent journey into the deep southern sky of interstellar space. It was a final, dramatic parting gift from the solar system, where the gravity of the furthest planet launched our mechanical ambassador into the true wilderness of the galaxy. This elegant alignment of mass and motion shows how humanity can navigate the deep dark, using the giants of the void to chart a path into the eternal silence. If we could project our senses deep beneath the blue cloud decks into the realm of supercritical fluids, we would experience a totally alien acoustic environment. Because the atmosphere thickens continuously into a dense, high-pressure slush, the physical properties governing sound waves change completely compared to the air of Earth. In this thick medium, sounds travel at exceptional speeds, moving multiple times faster than they do through our familiar terrestrial atmosphere. However, the heavy, dense molecules of hydrogen, helium, and methane act as a powerful dampening blanket, absorbing the energy of sound waves over very short distances. Any massive atmospheric disruption or supersonic wind howling through the depths would be muffled into a deep, heavy thud, unable to carry its voice across the planet. This creates a strange landscape of muffled intensity, an acoustic sanctuary where the grandest storms operate in a state of heavy, suffocating silence. The violent interactions within the lopsided magnetosphere produce a continuous stream of powerful radio emissions that sing out into the dark space. Voyager 2 detected these signals as a complex mixture of smooth, continuous hums and sharp, erratic bursts of electronic static. These radio voices are generated as charged particles are accelerated along the tilted magnetic field lines, crashing into the upper atmosphere to create the infrared aurorae. Because the planet spins so rapidly, these radio emissions pulse with a regular 16-hour rhythm, acting like a cosmic lighthouse, signaling its presence to the wider universe. This electronic signature remains entirely hidden from our natural senses, a chaotic song of plasma and magnetism played across frequencies that only our machines can translate. It reminds us that the quiet, serene blue sphere we observe from a distance is enveloped in a loud, energetic dialogue of electromagnetic forces. In the modern exploration of worlds orbiting distant stars, Neptune has achieved a grand new significance as the universal archetype for an entire class of planets. Exoplanet hunters have discovered thousands of worlds across the galaxy that possess nearly identical sizes and masses to our own blue giant, naming them sub-Neptunes or hot Neptunes, depending on their proximity to their parent stars. Many of these alien worlds orbit incredibly close to their suns, experiencing extreme temperatures that cook their atmospheres into raging torrents of exotic gases. By studying the deep interior, magnetic field, and cloud layers of our own accessible ice giant, scientists can construct accurate models to understand these distant, alien systems. Our lonely sentinel at the edge of the solar system has thus become the vital key to unraveling the geology and weather of countless worlds scattered throughout the Milky Way. It shows that the unique architecture of this blue Titan is a common and fundamental design chosen by nature across the wider cosmos. Standing as the final true planet, Neptune establishes the fundamental boundary that separates the organized solar system from the vast wilderness of the trans-Neptunian region. Every celestial body that resides past its orbit is measured and categorized by its relationship to the gravity of this blue giant, defining the architecture of the deep outer frontier. This region is populated by trillions of icy remnants, dwarf planets, and dormant comets that represent the pristine, unaltered material of the early solar nebula. Neptune acts as the gatekeeper to this dark realm, its gravitational presence dictating which objects are allowed to enter the inner system and which remain cast out in exile. To look past the sapphire clouds of this planet is to face the true, unmapped expanse of interstellar space, where the influence of our sun slowly fades into the starlight of the galaxy. It leaves the planet as a magnificent, solitary outpost, a beautiful blue border post marking the edge of everything we know. As we peer deeper past the outer boundaries of this blue Titan, we observe its profound influence on the wider structure of the Kuiper belt, specifically creating what astronomers call the Kuiper belt edge. For reasons that long mystified scientists, the dense population of icy bodies drops off precipitously past a certain distance from the planet's orbit. This sudden cosmic cliff is the direct handiwork of Neptune's ancient gravitational sweeping, which effectively truncated the outer ring of primordial material during its outward migration. The planet acted like a majestic gatekeeper, ensuring that the space immediately beyond its reach was cleared of large, unregulated debris fields. This clean boundary leaves a haunting gap of quiet space before the truly distant components of the outer cloud begin their infinite drift. It showcases how a single massive world can sculpt the architecture of an entire zone of the solar system, imposing a quiet geometric order on a field of wandering ice. The gravitational grip of the ice giant also dictates the behavior of long-period comets that descend from the outermost wilderness toward the warmth of the sun. As these pristine bodies of ice and dust fall inward from the Oort cloud after millions of years of silent travel, they must pass through the gravitational gauntlet managed by Neptune. The planet's massive field acts as a cosmic redirector, either flinging these travelers entirely out of the solar system into interstellar space, or pulling them into shorter, regular paths. This continuous manipulation alters the comet population over eons, turning Neptune into an active defense shield that monitors the cosmic traffic heading toward the inner planets. Watching this process from afar reveals a slow, patient choreography where wandering blocks of ice are tamed or exiled by the steady pull of the sapphire giant. It reminds us that our own peaceful existence in the inner system is quietly guarded by the operations of this distant sentinel. When we look closely at the smallest inner moons like Thalassa and Naiad, we find that their physical bodies are likely not original structures from the dawn of creation. Instead, planetary scientists believe these small, irregular rocks are generational fragments, having been pulverized and reformed multiple times throughout the planet's history. The intense bombardment by wandering comets in this crowded inner system means that any small moon is periodically shattered by high-velocity impacts in the dark. The resulting debris does not escape, but spreads into temporary rings before slowly coalescing back together under the influence of mutual gravity to form a new, clean moon. This continuous cycle of destruction and rebirth transforms the inner satellite system into a living, shifting environment where time rewrites the shapes of the rocks. It presents a beautiful concept of cosmic recycling, where the building blocks of moons are broken apart only to find each other once more in the quiet orbital tracks. The slow thermal evolution of Neptune over billions of years suggests that the heat radiating from its interior is escaping much slower than standard thermodynamic models would predict. This delayed cooling is a direct result of the immense density and specific composition of the water and ammonia mantle hiding beneath the clouds. As the planet slowly loses its ancient energy to the cold void, the internal materials undergo a continuous process of gravitational differentiation, where heavier elements steadily sink deeper toward the core. This slow, internal settling releases a steady supply of fresh gravitational energy in the form of heat, constantly replenishing the furnace from within. This self-sustaining mechanism explains why the planet has maintained its highly energetic weather systems for more than 4 billion years without freezing into a state of total atmospheric stagnation. It leaves the planet as a masterfully insulated engine of nature, pacing its thermal expenditure over lifetimes that span the existence of the universe. In sharp contrast to the wild, highly stretched trajectory of the distant moon Nereid, the orbits of Neptune's innermost satellites are spectacularly regular and circular. These inner worlds travel along paths that are almost perfectly aligned with the planet's equator, showing virtually zero tilt or eccentricity as they circle the blue giant. This immaculate precision is the result of eons of tidal circularization, where the massive gravitational pull of Neptune has smoothed out any wrinkles or wobbles in their ancient paths. The continuous rise and fall of gravitational tides between the planet and the close moons act like a gentle, invisible hand that rounds out their journeys over millions of years. It reveals a beautiful process of orbital calming, where the initial chaos of planetary formation is slowly polished into a state of flawless, geometric perfection. Moving along these smooth tracks allows us to appreciate the ordering power of gravity, which transforms erratic movements into a permanent, predictable ballet. Modern astronomers studying the total brightness of Neptune have detected subtle, long-term fluctuations in how the planet reflects starlight over many years. This global variability shows that the entire planet experiences a rhythmic process of atmospheric breathing, where the overall cloud cover expands and contracts in a slow, harmonic pattern. These large-scale changes alter the total albedo of the sapphire sphere, causing it to appear slightly brighter or darker when viewed from immense interstellar distances. This global pulse is driven by a complex interplay between the deep internal heat convection and the varying intensity of the solar cycle we explored earlier. It turns the giant blue ball into a dynamic, living world that signals its shifting internal states across the dark void through subtle variations in reflected light. Observing this grand rhythm invites us to view the planet not as a static object, but as a breathing entity operating on a magnificent timescale. Deep within the upper stratosphere, an invisible rain of high-energy galactic cosmic rays constantly collides with the methane molecules floating in the air. These powerful particles, traveling across the galaxy from distant supernova explosions, penetrate the upper layers of Neptune's atmosphere and strip electrons from the gas atoms. This continuous ionization creates a specialized layer of charged particles that acts as a catalyst for the formation of complex cloud structures deep below. These ionized molecules attract floating hydrocarbons, acting as tiny seeds or cloud condensation nuclei around which white methane ice can easily freeze and grow. This means that the spectacular storms and white ribbons of cloud we observe on this distant world are partially sculpted by forces originating outside our solar system entirely. It weaves a stunning connection between the weather of a lonely ice giant and the energetic currents of the wider Milky Way galaxy. Stepping just outside the thin edge of Neptune's exosphere reveals a realm of absolute and profound physical silence that contrasts sharply with the chaotic forces below. In this open vacuum, the density of matter drops to near zero, leaving only the ghost-like threads of the planet's lopsided magnetic field to trace the empty space. The roaring supersonic winds and muffled acoustic thuds of the deep supercritical ocean cannot cross this threshold, leaving their immense energy completely trapped within the blue shroud. Out here, the stars shine with a steady, unblinking brilliance, casting their cold light onto the silent sapphire disk resting quietly in the void. This boundary represents the absolute peace that guards the outer edge of the planetary system, a place where the activity of nature falls quiet once more. Floating in this silent space allows us to witness the grand juxtaposition of a world that is internally roaring, yet externally wrapped in the eternal, unyielding stillness of the universe. When scientists plan future automated missions to explore this distant frontier, they must overcome the immense challenge of decelerating a spacecraft arriving at extreme speeds. A probe traveling from Earth across 3 billion miles of space would possess far too much kinetic energy to simply slip into a stable orbit using conventional chemical fuel. To solve this engineering puzzle, experts design concepts that utilize a daring technique known as aerocapture, where the spacecraft plunges briefly through the upper mists of Neptune's atmosphere. The thick gas creates a precise amount of atmospheric drag, acting as a natural brake that slows the machine down safely without consuming valuable fuel reserves. This maneuver requires an immaculate understanding of the planet's atmospheric density, forcing the machine to skim the edge of supersonic winds before rising back out into a permanent orbit. It represents a beautiful future dialogue between human technology and planetary physics, using the very air of the giant to secure a permanent home among its moons. As we prepare to conclude this phase of our long, drifting journey, we can appreciate Neptune as the ultimate monument to the predictive power of mathematical physics. Its very existence reminds us that human logic, operating in a quiet room with simple pen and paper, can map the structures of the universe long before our eyes ever look upon them. The blue giant was found because humans trusted the unbending laws of gravity, tracking the subtle whispers left by an unseen world in the path of its neighbor. It stands as a beautiful testament to the ordered reality of our cosmos, where every mass, no matter how distant or hidden, leaves an undeniable mark on the fabric of space. Contemplating this truth brings a sense of deep intellectual peace, showing that the universe is not a chaotic wilderness, but a finely tuned symphony governed by elegant and knowable truths. Let us rest our minds now against this backdrop of mathematical harmony, allowing the steady, slow rhythm of the sapphire giant to guide our thoughts into the quiet dark. The profound gravitational authority of the blue giant extends deep into the frozen wilderness, organizing the wandering paths of thousands of icy bodies into distinct mathematical families. Beyond the well-known relationship with Pluto, An entire population of objects known as plutinos and teutinos are held in strict orbital locks by Neptune's steady pull. These distant frozen rocks are compelled to sync their journeys with the giant, moving in perfect harmony to ensure they never experience a disruptive close encounter. It is an immense celestial choreography that extends across billions of miles, demonstrating how a single massive world can bring order to a chaotic field of debris. This unseen web of resonance transforms the outer frontier into a structured gallery of motion, where every small traveler follows a script written by the gravity of the ice giant. As the ice giant moves through its endless orbit, it casts an immense cone of absolute shadow out into the deep void, a realm of total darkness stretching for millions of miles. On this permanent night side, away from the faint glint of the distant sun, the atmosphere enters its most profound state of quiet cooling. Without any solar light to illuminate the upper mists, the deep blue color fades into an impenetrable blackness that blends seamlessly with the open universe. Yet, even in this hidden shadow, the planet's internal fires continue to churn the mantle, driving the supersonic winds across the dark hemisphere in total silence. It is a world of dual realities, where a face of brilliant sapphire constantly turns into a dark abyss of hidden energy and whispering currents. Humanity's dream of returning to this distant sapphire sanctuary relies on developing advanced technologies capable of operating far beyond the reach of solar power. Because the sunlight is too faint to charge traditional solar panels, any future robotic orbiter must carry its own internal power source, utilizing the gentle, steady decay of radioisotope thermoelectric generators. These nuclear hearts will provide the vital warmth and electrical energy needed to keep instruments alive in the absolute cold of the outer system for decades. This technological limitation requires us to build machines that are completely self-sustaining, carrying a spark of human ingenuity into the deepest shadows of the cosmos. It highlights the incredible contrast between the fragile, warm creations of humanity and the immense, freezing environments they are sent to explore and understand. When we contemplate the distant future of our solar system, Neptune stands out as a world that will survive the ultimate transformation of our parent star. Billions of years from now, when the sun expands into a massive red giant and swallows the inner rocky worlds, its destructive reach will slowly fade before reaching the outer system. While the intense heat will melt the icy surfaces of the outer moons, Neptune's deep, high-pressure atmosphere will remain largely intact, shielded by its immense distance. The giant will watch the slow death of its creator from a safe sanctuary, its deep blue clouds turning quietly in the changing light of a dying star. This extraordinary longevity ensures that the ice giant will remain a monument of planetary architecture long after the cradle of Earth has ceased to exist. The delicate rings that encircle the equator of the planet are not static, permanent features, but are dynamic structures undergoing a continuous process of erosion and renewal. The tiny dust particles that make up these dark bands are constantly colliding with one another, grinding down into even finer mists over thousands of years. This slow destruction is balanced by the continuous influx of fresh material, blasted off the surfaces of the nearby inner moons by microscopic meteorites. This means the rings we observe today are relatively young and shifting, a temporary display of cosmic dust that changes its shape over geological eras. It reminds us that even the most structured features of a planet are part of a living, evolving system that continuously recreates itself in the dark. The rapid 16-hour rotation of the planet shapes its physical body into a distinct geometric form known as an oblate spheroid, where the globe is visibly flattened at the poles. This distortion is caused by the immense centrifugal force generated as the massive ball of gas and ice spins swiftly upon its axis. A traveler measuring the distance from the center to the equator would find it significantly wider than a measurement taken from pole to pole. This physical bulging influences the local gravitational field, creating subtle anomalies that alter the paths of the inner moons and rings as they circle the giant. It shows how the simple act of motion can reshape the very geometry of a massive Titan, molding its form into a testament of kinetic energy. Long before a mechanical spacecraft provided our first clear images of the planet's rings, astronomers detected their hidden presence through a beautiful technique called stellar occultation. By watching Neptune pass directly in front of a distant, flickering star, observers noticed that the starlight blinked out briefly before and after the main body of the planet blocked the view. These fleeting interruptions revealed that invisible bands of material were hiding in the dark space surrounding the sapphire giant, waiting to be mapped. This elegant discovery demonstrated that the light of the most distant stars can be used as a natural flashlight to illuminate the darkest structures of our own solar neighborhood. It emphasizes the profound interconnectedness of the cosmos, where a spark from a distant galaxy can unveil a hidden secret at the edge of our system. The massive, captured moon Triton leaves a permanent, invisible imprint on the environment of its master as it journeys along its backward path through space. As the moon's active nitrogen geysers spew material into the thin vacuum, a cloud of neutral atoms escapes its low gravity and spreads out into a giant ring around Neptune. This icy torus interacts directly with the planet's lopsided magnetic field, absorbing energetic particles and altering the flow of the magnetosphere. The moon essentially feeds material into the planetary shield, creating a unique relationship where a satellite actively modifies the electromagnetic environment of its parent world. It is a stunning display of cosmic feedback, showing that a captured wanderer can reshape the invisible forces of the Titan that ensnared it. If an explorer could turn their gaze away from the deep blue clouds of Neptune and look back toward the center of the solar system, our home planet would appear completely transformed. From this staggering distance of 3 billion miles, the Earth is reduced to a microscopic speck of light, entirely lost in the brilliant glare of the distant sun. All of human history, our grand civilizations, and our deepest oceans are condensed into a single, invisible pixel drifting in a vast ocean of darkness. This perspective strips away all human pretense, leaving us with a profound sense of humility and wonder at the sheer scale of the universe we inhabit. It reminds us that our world is merely a fragile oasis, safely nestled in the inner warmth, while the giants of the void hold their long, silent vigils in the outer dark. Standing as the final, magnificent monument of the true planetary system, Neptune represents the perfect synthesis of cosmic order and wild, primordial energy. Its deep blue atmosphere, howling with supersonic winds and raining with flawless diamonds, serves as a beautiful reminder of the limitless creativity of natural laws under extreme conditions. The planet rests quietly at the edge of the great interstellar wilderness, a serene sapphire guardian that marks the boundary between the sun's domain and the infinite stars of the galaxy. As we watch its slow, 165-year journey through the velvety dark, we are invited to let go of our terrestrial thoughts and surrender to the grand, patient rhythms of the deep cosmos. It leaves us in a state of absolute peace, a silent sanctuary where the boundaries of space and time dissolve into a permanent, beautiful harmony. Our long, drifting journey through the outer reaches of the solar system is slowly drawing to its natural close, leaving us suspended in the quiet dark at the absolute boundary of the sun's influence. Behind us rests the magnificent sapphire giant, a solitary guardian whose roaring supersonic winds and glittering diamond storms continue to play out in timeless, elegant isolation. We have traced the invisible threads of gravity that bind this distant world to its court of 14 moons, witnessing the majestic, backward dance of Triton and the fragile architecture of the dark dust rings. Every scientific truth we have uncovered serves as a beautiful reminder of the deep order that governs the universe, a melody of physics and chemistry echoing across billions of miles of silent space. The dizzying speed of the planet's 16-hour day and the grand, slow rhythm of its 165-year orbit now blend together into a single, calming perspective. As we step back from the cloud decks and allow our consciousness to float away into the open void, the energetic forces of the ice giant transform into a serene, distant memory. Looking out from this final outpost into the deep interstellar wilderness, the overwhelming vastness of the cosmos becomes a source of profound comfort and stillness. The immense distances that separate the worlds are not empty voids of loneliness, but gentle, peaceful sanctuaries where the noise and chaos of everyday life are completely washed away. In this quiet realm, the faint starlight shines with a steady, eternal brilliance, anchoring our thoughts in a reality that is grand, patient, and beautifully ordered. The planet Neptune has shown us that nature crafts wonders of unimaginable scale in the dark, balancing hearts of roaring warmth with outer shells of absolute winter. This magnificent equilibrium reflects the deeper nature of the universe itself, a continuous dance of energy and peace that operates flawlessly across the eons. By connecting our minds to these distant, icy frontiers, we allow our own inner storms to settle, mirroring the ancient stability that followed the chaotic eras of planetary migration. The time has come to let go of our searching questions and surrender fully to the majestic silence that wraps the outer edge of everything we know. The sapphire disk of the guardian planet is slowly fading into the background of 1,000 distant stars, its deep blue hue dissolving smoothly into the rich, velvety blackness of the open galaxy. We leave behind the exotic states of matter, the twisted magnetic fields, and the echoing radio songs, allowing them to drift safely in the grand archives of the cosmos. The universe remains wide and beautifully secure, guided by elegant laws that require nothing from us but our quiet appreciation. Let your thoughts wander out into this infinite, peaceful frontier, where the boundaries of time and space gently blur into a state of permanent rest. Sleep safely now in the knowledge that you are a part of this grand, harmonious design, floating peacefully through the eternal, silent dark.